Hello friends, welcome back. Let's look at this interesting example related to trigonometry 10th grade syllabus. We have been given a square plus b square multiplied with secant theta minus 2ab tan theta equal to a square minus b square. We have to find out what is the value of sin theta. Now how to solve this problem? So first let us see what are the trigonometric ratios we have in the problem given. We see that there is secant theta and there is tan theta. We have secant theta and tan theta, and I have secant theta, tan theta in the problem, and we also know what is the relation between secant theta and tan theta. We know that there is an Pythagorean identity which says that secant square theta minus tan square theta equal to 1, or secant square theta is equal to 1 plus tan square theta. We know that. So to solve this problem, what we will do, we will try to convert this. You can actually convert this whole problem into either secant square theta or tan square theta. To be precise, we want to convert that into a quadratic equation so that we can use the quadratic formula, or we can use the splitting the middle terms, and we can find out what is the value of secant theta or tan theta. You know that once you know one trigonometric ratio, you can get all of them by using the triangle. If you just draw the triangle and put down one angle, one trigonometric ratio, you will get all of them. We will see that. So my idea, I am starting with, I want to find out what is tan theta now. From this problem I want to find out what is tan theta. So for that, this secant theta I have to convert that into first secant square theta, then I have to convert that into 1 plus tan square theta. So idea is first convert secant theta into secant square theta, then write it as 1 plus tan square theta. If I am able to do that, then I will have a quadratic equation in tan, which will give me what is the value of tan theta. So let's do that. To do that, a square plus b square secant theta, we will leave this and take 2ab tan theta to the right hand side. So I will have my first step as a square plus b square into secant theta is equal to a square minus b square plus 2ab tan theta. We haven't done anything, just we have moved 2ab tan theta term to the right hand side, because you remember our idea was to convert this secant theta into secant square theta, then apply the Pythagorean identity or trigonometric identity and convert that into tan. Okay, now how to convert secant into secant square theta? You can do that only by squaring. So let us do square on both sides. If we square on both sides, what we will have? We will have a square plus b square whole square secant square theta is equal to a square minus b square plus 2ab tan theta whole square. So if we square it on both sides, we also call it as SOBS. We just do squaring on both sides. We will have a square plus b square whole square equal to secant square theta equal to a square minus b square. Now this is in the form of a plus b whole square. You know what is the formula for a plus b whole square, which is equal to a square plus 2ab plus b square. So let's simplify that and write down the next step. We will go to our next step. Our next step will be a square plus b square whole square. I have written it already here. Now this secant square theta, I can write it as 1 plus tan square theta if you allow me. Why I want to do that? Because by doing that I can have a quadratic equation in tans. That will make it into 1 plus tan square theta. Now you have a plus b whole square formula. So my a is a square minus b square. So a square will be a square minus b square whole square plus b is 2ab tan theta, so b square will be 4a square b square tan square theta, 4a square b square tan square theta. Then you have 2ab term is equal to 2 into a into b, that means 2 into a square minus b square into 2ab tan theta. So can I write it as 4ab into a square minus b square tan theta. So this is the equation we have now. If you observe now, in trigonometric ratios we have only tan theta there, nothing else. We have tan square theta, we have tan square theta another term, we have constant term, and we have one tan theta. That means we successfully converted the given equation into a quadratic equation of tans. So now I should be able to find out the tan theta after a little bit of simplification. So let's go back to our next step on the simplification. It will be a square plus b square whole square. The first term, multiply this with 1, then I have to multiply with tan square theta. It will become a square plus b square whole square. I have tan square theta is equal to a square minus b square whole square. I will leave it. Oh, okay, let's do one thing. Let's get everything onto the left hand side so that we can make it equal to 0. So this will become minus of a square minus b square whole square minus 4a square b square tan square theta minus 4ab into a square minus b square into tan theta equal to 0. I hope you are okay with that last step. What we have done, we have moved everything to left hand side and equated to 0. A square plus b square whole square plus a square plus b square whole square tan square theta minus of a square minus b square whole square minus 4a square b square tan square theta minus 4ab into a square minus b square tan theta equal to 0. Let's go to the next. Our next step is we will look into the like terms and we'll try to simplify. I see one like term here and tan square theta related. So let me just write it down. I will say a square plus b square whole square minus of 4a square b square, this whole thing, tan square theta, that's the something like ax square. Now let us look at our bx, ax square plus bx plus c. Where is our tan theta? Tan theta is minus 4ab into a square minus b square into tan theta. So we have ax square plus bx plus c. C is nothing but our constant term. So which is equal to, I will write down here, plus a square plus b square whole square minus a square minus b square whole square. Now we have to understand one simple formula here before we move forward. The formula, I'll just write it down here. The formula is a plus b whole square minus a minus b whole square is equal to 4ab. If we are able to understand this formula, then this becomes pretty easy to solve. Okay. Now what is a square plus b square whole square minus 4a square b square? It is in the form of a plus b whole square minus 4ab. It is in the form of a plus b whole square minus 4ab. And here we are in the form of a plus b whole square minus a minus b whole square. So let us try to simplify this. Because we know this formula, we can leverage that formula and we can simplify it very easily. So my next step will be a plus b whole square minus 4ab is, I know that a minus b whole square, and a is a square here, b is b square. So I'll have a square minus b square whole square tan square theta minus, I can't do anything with the tan theta term, so I'll leave it as it is, 4ab into a square minus b square. And look at the next term, a plus b whole square minus a minus b whole square is 4ab. 4, a is a square and b is equal to b square. This is equal to 0. Now this is the equation which we are interested in. Now you can see this is of the form of ax square plus bx plus c, where x is a function of tan theta. We have in terms of tan theta. Okay, this is what we have now. We know how to solve this by using the splitting the middle terms. Now what I want to know here, I have to get sum is equal to minus 4ab into a square minus b square, and the product is equal to 4a square b square into a square minus b square whole square. Now how I can factorize this? So we want sum minus 4ab a square minus b square, and the product is 4a square b square into a square minus b square whole square. So can I write it as minus 2ab into a square minus b square, and the other one is also minus 2ab into a square minus b square, so that when you add them up you will get minus 4ab into a square minus b square, and when you multiply you will get 4a square b square into a square minus b square whole square. I know there are so many squares, it's a little bit confusing, but I think you should be okay with that if you follow me right. Now what will be my next step? To use the splitting the middle terms, because we just now found the term can be, the middle term can be split into two. So what is that we got now? A square minus b square whole square tan square theta minus 2ab. Oh, by the way, there is a tan theta here. That's, if I don't put it then it won't make sense. 2ab into a square minus b square into tan theta minus 2ab into a square minus b square tan theta, and at the end we have plus 4a square b square. So we have couple of steps more. With that we should be able to find out our tan theta. Let's do that. Let's now factorize this. We can do this as, I can take a square minus b square into tan theta common. If I take it common, I'll have a square minus b square into tan theta minus 2ab minus of, I can take 2ab common in the next two terms. So I'll have 2ab into a square minus b square tan theta minus 2ab, which is equal to a square minus b square tan theta minus 2ab whole square equal to 0. So that tells me that a square minus b square into tan theta equal to 2ab, or can I write tan theta equal to 2ab by a square minus b square. Now once we find out tan theta, how to find out the sin theta? Let's have a look. So tan theta equal to 2ab by a square minus b square looks like this in right triangle. We have tan theta, opposite side by adjacent side is 2ab by a square minus b square. If you apply Pythagoras theorem, you will find out that this is equal to a square plus b square. So what is sin theta now? Sin theta is equal to opposite side, that is 2ab divided by hypotenuse, that's equal to a square plus b square. Now how we got a square plus b square? We know that a square plus b square whole square is equal to a square minus b square whole square plus 4a square b square. So or we know that square of hypotenuse is equal to sum of squares of remaining two sides in a right triangle. That's how we can say sin theta equal to 2ab by a square plus b square. In the similar fashion you can have two more problems. Let me just try to give it to you so that you can try them on your own and see the same logic. Either you want to go for, suppose it is sin and cos, first decide whether you want to go for sin or cos. Convert it into a quadratic equation of that trigonometric ratio, then solve it and find it out. So let me give you a couple of more problems for practice in the same lines with the same type of problem. You can try these two problems which are based on the same lines. One is a square minus b square into cos theta plus 2ab sin theta equal to a square plus b square. Find the value of tan theta, whatever trigonometric ratio you want, because you can, once you know, you can find out one, you can find out all of them. In all of them, the tan theta will be nothing but a square minus b square by a square plus b square. Tan theta will be nothing but equal to 2ab divided by a square minus b square in all these three problems, because they are all based on, actually, if you observe, I suppose, let us say this a square plus b square, I bring it to here. I have a square minus b square by a square plus b square cos theta plus 2ab by a square plus b square sin theta equal to 1. So it should be in the form of cos square theta plus sin square theta equal to 1. Then cos theta is a square minus b square divided by a square plus b square, and sin theta is 2ab by a square plus b square. So you can try these two problems and check whether you are getting the same triangle for the remaining two problems also. I'll catch you once again with another interesting example. Thanks for your time and support. Bye for now.